The final thing we need to know when we're dealing with quadratics and radicals is what happens when we end up with the square root of a negative, which you've not seen before in my class. If you put the square root of negative 25 in your calculator, it'll say error. So we need to understand what the hell this means. So right here, the square root of 25 we know is 5 or negative 5. Because 5 times 5 is positive 25, negative 5 times negative 5 is positive 25. And that's the definition of a square root. Your answer needs to be multiplied with itself to get back to what you started. So we have 5 or negative 5. So if we think about the square root of negative 25, is there a number times itself that can get back to a negative? And the answer is no. There's no real number that exists, like 5 times 5 is 25, negative 5 times negative 5 is 25. No real number exists for the square root of negative 25. So we have to have something called imaginary numbers. And the biggest thing to understand in math is whenever you see the little I squared is the same thing as negative 1 every single time. So when we are answering a question like the square root of negative 25, all we need to know is that I squared will equal negative 1. So when I come up here and start breaking this down, I'm going to first separate out negative 1 times 25. Because I think we can all agree, negative 1 times 25 is negative 25. Now for the rest of your mathematical career, if you have a negative 1 underneath a square root, that can be split into a pair of i's. I squared is the same thing as negative 1, which is just I times I. I times I is the same thing as I squared. Then we have 5 times 5 here. So if we notice with the El Chapo method, 1 5 dies, 1 5 escapes. 1 I dies, 1 I escapes. There's nothing else underneath. That is technically my final answer for the square root of negative 25. You get 5i. It's an imaginary number. And if you wanted to prove this, just like 5 times 5 is 25, negative 5 times negative 5 is 25, well, let's try this out. 5i times 5i should get us back to the original. 5 times 5 is 25. I times I is I squared. And in our math, I squared is the same as negative 1. So whenever I squared pops up, we can swap that out with a negative 1. And we can see how we get to negative 25 again. So now you'll notice that sometimes in your quadratic formula, you're going to start simplifying down to answers like this. Now, once again, your last step needs to be, can any of the outside escaped numbers be reduced? That 4, 6, and technically there's a hidden 1 out there. So the 4, 6, and 1, there's no common factor, but we need to see if we can reduce this. And anytime it's negative, no matter what, you must reduce the negative out of the square root. So I'm first going to separate out negative 1 times 20. Whenever you have a negative, go ahead and separate that negative 1. Because now we know negative 1 is the same as I squared. So negative 1 will give me a pair of i's. And now we'll start breaking down 20 like normal. Do 2 times 10. 2 times 5. See a pair of 2's down there. So it looks like this is going to reduce to 2i on the square root of, it looks like there's still a 5 at the bottom there. And now your last step, is there a common factor here? Yes, there is. Everything can be divided by 2. 4 divided by 2 is 2. 2 divided by 2 is just 1i. We don't have to include the 1. We don't touch the square root of 5. 6 divided by 2 is 3. That would be your final imaginary answer. Let's try it out up here. So the first thing you do when you see a negative is go ahead and separate out, because now negative 1 is the same as I squared. So I can give a pair of i's out of that negative 1. Then I can start coming down here. So it looks like this is going to end up simplifying as 5i. And it looks like that square root of 2 is left underneath. And now ask yourself, is there a common factor between the outside escaped numbers? Yes, we can divide by 5 to get our final answer.